Hello everyone, my name is Ryan Riley. Welcome to the Computer Security course here at Qatar University. Now, let's go ahead and let's talk a little bit about the course. So high-level information. As I said, my name is Ryan Riley. My office is in the Engineering Annex building, upstairs in room 205. Now the Engineering Annex building is kind of that strange building at the end of Corridor 7 on the male campus. If you've never been there before, just call me. My number is 4403-4261, and I can meet you to bring you there if you're trying to find me. The course website for this class is going to be on Blackboard, which hopefully you figured out by now, because if you're watching this video, that means you made it successfully to Blackboard. That's where we'll post things like videos, lecture slides, or other material about the course. The syllabus is also on Blackboard, and it's very important that you go and you actually take a read through the syllabus now. Okay, so this is a computer security course. What kind of prerequisites do you need? Well, it's required that you have some basic networking and a basic understanding of computer organization, and that was probably enforced by the prereqs you had to have before you even signed up for the class. It's useful if you've had any sort of background in Linux or some sort of other Unix. If you haven't, that's okay, you'll make it, but if you have some background, that'll be helpful for you. And it's also useful if you've already taken or are currently taking operating systems. But again, not required, just useful. The most important thing you need for this class is a desire to learn and experiment. So there are three main course goals. The first is I want you to learn how to apply the security mindset. And the security mindset is simply a way that you begin to think about problems and systems from a security perspective. You begin to think about how you can improve those systems to make them more secure, or you begin to think about how you could break those systems to make them less secure. Once you understand and have the security mindset, it's something that you'll do naturally. It just becomes a part of your life as you analyze and think about the systems that you interact with every day. So for example, whenever I fly internationally or whatever and I go through the airport, I'm always thinking about what's the security of the system set up. You know, you go through x-ray machines, they x-ray your baggage, they run you through metal detectors. They do all of these things. I'm always thinking about how is this system working well to protect our security? How is it failing? What are the things that they're doing that don't actually help security? What are the things they're doing that do help security? How can I beat this system? Et cetera, et cetera. I do it naturally now because I think with the security mindset. Drives my wife crazy, actually, because I'll always go through airport security, and then at the end I'll talk about all the things that they did that don't help security at all, or I'll talk about things that they should have done but didn't. It's just kind of the way things are. The second main course goal is I want you to learn a little bit by experimenting with some security tools. These are actual tools used in practice by both security professionals and attackers. And these are tools that are good for attacks and defense. And I want you to be able to experiment with them. We're going to use those as part of homeworks during the class. And the third main course goal is I want you to learn the security fundamentals. And I'll just call that some of the core knowledge about the field. And most of that will be encompassed in some of the early weeks of the class. I'll try to give you a good core foundation. And then we'll talk about specific topics within security where you can apply some of those core skills. How about some things that are not course goals? So this is a computer security course for you, undergraduate students. My goal is not to make you experts in security, because I can't. It's too broad of an area. It's huge, and it covers too much. Security is kind of what we call a cross-cutting area. Cross-cutting meaning that it applies to every other part of computing. So if you're building a website, there's a way that security applies to that. If you're designing an app for a phone, there's a way that security applies to that. If you're building an embedded system, there's a way that security applies to that. So security applies to all of the areas in computing, and I can't cover all of that in one course, so I'm not even going to try. Instead, I'm just going to pick a scattering of items from security that we'll be discussing. I'm also not really going to be discussing the legal and economic impacts of security. We'll touch on these a little bit. So for example, what's the legal framework in place for dealing with security attacks, or how much money does an attack cost a company when it occurs? These are important parts of security, but it's just I don't have enough time in this course, so I'm not going to spend much time on them. And lastly, it's also not a course goal that you learn to hack or crack into computers. This is not a hacking class. My goal isn't to teach you how to break into other people's machines. Now that said, we will actually be using real attack techniques and tools. So you will learn some things that could be put to bad use. And so I want to make this quick note on ethics. We're going to be learning these potentially bad attacks. And I do that. I teach you that because I think that in order to provide good defense, you need to understand how attacks work. But as I teach you that, I want you to understand that you're not to use any of the material that we talk about in this class against people or computers that you don't have written permission to apply it to. So, for example, we talk about wireless network security later on in the course, and I may show you ways that you could decrypt encrypted traffic on a wireless network. Well, if you want to experiment with that and set up an access point on your own and play with it, that's fine. But if you start doing that on your neighbor's access point, well, that's not okay. Or if you apply some of these attacks here at QU, that's not okay. So only do things that you have written permission for. So as a whole within security, let's kind of talk about the vulnerabilities and stuff that are impacting the world as a whole. So this is an interesting graph. Software vulnerabilities. Now, a lot of attacks that occur online occur because some piece of software is vulnerable, and attackers figure out how to use that to their advantage. So this is an interesting graph from the National Vulnerability Database. And what this graph shows is that starting in 1988, that's when this system was first done, it kind of looks like it's 0, but it's actually in the single digits. There's anywhere from 0 to 10 or so different software vulnerabilities reported into this database. And that part of that is because there really weren't that many software vulnerabilities being studied, and legitimately another part is that people weren't reporting them to the database. But starting about 1998, reporting really took off. And you can see that every year from 1998 until about 2006, there's a very strong upward trend. And what this is showing us is that every year there was more and more software vulnerabilities being shown. And each of those vulnerabilities can potentially be used for an attack. So from about 98 to about 2006, there was a lot of vulnerabilities being found every year. 2006 was kind of the peak here at around 6,500 different software vulnerabilities. Now, a software vulnerability could be something like Adobe Acrobat Reader has a bug that would let an attacker craft a malicious PDF to take over a computer. Software vulnerability could be some bug in Microsoft Windows that would let an attacker break in. There's all sorts of different definitions of software vulnerability. But then you can see that starting in about 2006, we kind of see this drop, and then I'll call it a leveling off. So what's happening is that security has become important to companies and to attackers and things like that. And so companies are beginning to address and try to do more secure software design. And at the same time, kind of the initial run of software vulnerabilities that people were finding were in software that the original designers didn't even think about security in. And so now, by the time we get to 2006, everybody's thinking about security when they design big software. And so we kind of get a leveling off. But still, we're looking at somewhere between 5,000 and 6,000 vulnerabilities a year reported for software that runs on people's computers. That leaves a huge opening for attackers to continue to commit attacks and break into people's machines. Okay, so let's talk about what kinds of things attackers are trying to get. So when you hear about big hacks that happen online, what are attackers trying to do? Well, one big thing they're trying to get is they're trying to steal personal data. So the biggest thing recently, of course, has been this Target breach mentioned in the US, where attackers actually broke into the computers of Target stores and installed malicious software that would grab credit card information. 70 million people were impacted by this. Now, to put that into perspective, that's 70 million people in the US. The population of the US is about 350 million. So 70 million of the 350 million people in the US were impacted by this breach. That's a huge percentage of US citizens impacted by an attacker breaking into Target. And other types of payment information have jumped significantly as well. Attackers are continually targeting stores, credit card companies, and banks. Why? Because if they can get your information about you at the bank and your account information, they can steal your money. This is an interesting article that came out of the China Post, but it's about South Korea. 20 million South Korean customers had their data leaked from banks, and these people got mad, and they actually kind of flooded banks and protested and did all sorts of things in response to the fact that these banks had not had good enough security to protect their customers' information. Another big thing in the news recently in terms of security attacks has been attacks by foreign governments. Most notably the U.S. in what it's been doing in attacking foreign governments. So here's an example here. This isn't the US, but GCHQ, which is the British spy agency, has found they've been tapping fiber optic cables for access to the world's communications. So they'll tap internet fiber optic cables in order to see the traffic from all sorts of other countries and individuals and people. That's a security attack. The biggest, of course, recent thing has been Edward Snowden and all of his leaks about what the NSA, which is the US's spying agency, has been doing worldwide. And all of those significant numbers have been computer security-based attacks. And going back a little bit older, you may vaguely remember hearing about Stuxnet, which was an attack that the U.S. and Israel teamed up to do against Iran to kind of lower their nuclear capabilities. Stuxnet really marked a major shift in internet security because it was the first widely regarded malicious software attack done by governments. And so that was a big change in the way we think about security. Previously, when we think about, what sort of people do attacks, we're not thinking about governments doing it. We're thinking about organized crime or individuals, but governments is kind of a big deal. And it isn't just happening worldwide, it's also happening here in the region. So in 2012, Saudi Aramco announced that they had been hacked and it attacked 30,000 of their workstations. That's a lot of computers. And around the same time, probably as part of the same attack actually, RasGas here in Qatar got hit by a significant attack. And RasGas was off the internet for months as a result of this while they tried to clean up and work on their security. They spent a lot of money and a lot of time and brought in a lot of consultants to come in and try and fix the security issues that they had. So what is security? How do I say that something is secure, or what does that even mean? So the Oxford Dictionary definition is that security is the state of being free from danger or threat. Now, that's kind of a vague term. So in the real world, what does security mean? Well, usually I use security in the real world to protect valuable things. I may have physical things I want to protect, money or jewelry or cars or my house or people. I want my family to be secure. I want my friends to be secure. Sometimes we protect access to places. So the classic example I laugh about here is the parking lot here at QU. There's a faculty and staff parking lot that in theory has security to protect access to it, so that only faculty and staff park there and not students. But, it seems that students park there anyway, but that's a different issue. So we use real-world security to try and protect things, and we can think about that. It's easy for me to reason about what sort of security would I need in place in order to protect my car from someone stealing it. I can think about that. So in a very real sense, we think of an item as being secure if no one can take it, harm it, or use it without our permission. So we're in control of it, and no one can take it, harm it, or use it. Now, when we start thinking about computer security, there's only one type of digital asset, and that's information. Everything about a computer, other than its physical existence, can be thought of as some form of information. So in computer security, we're concerned with protecting information. But protecting information is hard because it's small in a physical sense. We can store lots of information on very small portable devices. And lots of information can be accessed electronically. This is difficult. If I want to protect my car, well, my car is a large physical item. There are certain things that aren't going to happen. Someone is not going to just walk up, pick it up, and walk away with it. It's too big. But with information, you can't think of it that way. There's all sorts of ways someone could get to information. They could break into it electronically and steal a copy. I might not even know. They could steal the physical computer that it's sitting on. Information is much harder to think about from a security perspective. The internet has made this even more difficult because now a lot of our information is available to a worldwide network of people, and that makes it much harder to secure. So when we're thinking about securing information, there are three main security properties that we're concerned about. The first is confidentiality. And confidentiality is where we're trying to prevent unauthorized reading of data. The second is integrity, which is where we try to prevent the unauthorized modification of data. And at the same time, with integrity, we're trying to verify that the person who wrote the data is who they say that they are. Now, another important security property is availability, which is where we try to ensure that data is available to authorized people. These three together are kind of the three core security properties: confidentiality, integrity, availability. Anyone who studies security can tell you what these three properties are and what they mean. So be sure you can rattle these off really quickly, because someday you're going to be in a job interview and they're going to say, oh, you took security, so you know about the three main security properties. And you go, yes, confidentiality, integrity, availability, because that's the core. Let's look at some examples just so I can help you understand what those three are. So I have a son. My oldest son is in kindergarten. And so I did this example thinking of kindergartners. So we have Alice and Bob, and they're two kindergarten kids. They're young, whatever. They're in the same class. Bob decides that he really likes Alice, and so he wants to send her a love note. But Bob is 5. Bob knows that his friends are going to make fun of him if they know that he sent a love note to Alice. So he doesn't just want to send a love note. He wants to send a secret love note that no one else can read, so that only Alice knows what it says. And if anybody else happens to see it, they won't know what it says, because Bob's worried about his image. He doesn't want his friends to think that he, likes girls. So he wants to send this secret love note. Bob wants confidentiality. He wants his message to Alice to be confidential. He wants to make sure no one else can read it. Now, when it comes to integrity, let's say that Bob has sent his note, and he comes into school one day and finds a reply sitting on his desk. He's thrilled. Alice wrote him back. Everything is good. But then he stops and thinks, how do I know that this note actually came from Alice? And how do I know that no one else got here before me and changed what it said, even if it is from Alice? In that case, he wants integrity. He wants to be able to verify that the message he has is actually from Alice and hasn't been modified after she wrote it. Now, the third thing that Bob really wants is availability. Because now that he and Alice have established that they both like each other, they want to be able to send messages back and forth. So, they send messages back and forth, but what happens if the teacher finds out? Well, the teacher's going to get in the way. The teacher's not going to let them send notes back and forth. And so Bob wants availability. He wants to make sure that nothing gets in the way of him passing notes with Alice. Okay, so let's summarize what we talked about today. First, attacks are growing. The number of attacks that are occurring are continuing to grow, and the threats are continuing to grow, and they affect real people like you and me. Your information may get stolen by an attack against some bank or some other website that you do business with or even are just a part of. And the three main properties in computer security are confidentiality, integrity, and availability.